Lecture number 18. Actually, in today's lecture, we are going to study some properties of Laplace transform. We are going to cover section 7.3.1 from your textbook. Let me first of all do some revision about what we studied in the previous lectures of Laplace transform. If you remember, if I have a function f of t, and I need to find its Laplace transform, so the notation it will be Lf of t is given to be if capital of S. So I will give you a function of t and you will give me a function of S. Okay, and the definition of this given by the following: integral from 0 to infinity exponential negative st times f of t dt. And we studied the inverse Laplace transform, if you remember. And we have two tables, one for the Laplace transform and the second for the inverse Laplace transform. After that, we moved to how to find the Laplace transform, not for the function, but for its derivative. So if I need to find the Laplace transform of f prime, can anyone of you remember the rule of Laplace of f prime, the first derivative? Can anyone remember?
Yes. SF capital minus
SF
f of 0
minus f of 0. You are right. F small of 0. And by the way, if your function has a variable y, has the notation y, so my function it is y, and I need to find the Laplace of y prime is given to be sy capital minus y of 0. Okay. What about of the second derivative rule? So Laplace transform of second derivative of my function y. Do you remember? What do you think? Anyone of you remember the rule? You have to prepare your cheat sheet for the final exam. By the way, all the lectures in this week and not all the lectures in the coming one, only one of the coming lecture isn't about Laplace transform, but all the lectures also in the coming week about Laplace transform. So the Laplace transform is very important for the final exam. And by the way, for the engineering students, Laplace transform is very useful. So what do you think about this rule? Anyone if you remember your cheat sheet?
S squared f capital.
S squared y capital, you are right, minus?
SF sy of 0.
Yes, SF of 0 or y of 0, you are right, minus?
Sy prime of 0.
Y prime of 0, you are right. You need this rule and you need this rule. Actually, I must memorize those or write them in my cheat sheet because you need to use them to solve initial value problems. And don't forget, our aim to study Laplace transform here is to solve some initial value problems. Okay? So those what we studied in the previous lectures about Laplace transform. And today we are going to learn a new thing which will help me to find Laplace transform of some specific functions. Here are the objectives and the title of the theorem which we need to study today. It is first translation theorem or first shifting theorem. Now, if I ask you to find the Laplace transform of this function, I'm going to ask, maybe let me ask, I need to choose Rahma. Can you help Rahma? So I need to find Laplace transform of this function, f of t, which is given by this formula. Do you remember, Rahma, how to find Laplace transform of this function? What do you think, Rahma? Can you hear me, Rahma?
Yes, doctor.
Yeah.
It's going to be f of s, f capital of s.
Yes. So I understand. You will write f of s. Now my question, what is this f of s? I need you to find f of s for this specific function. So now find Laplace e to the 3t cosine 4t. For me, if I have only cosine 4t, so I will find it in my table. If I have only e to the 3t, I will find it in my table. What about if I have a product between them? By the way, before we start solving this problem, one of your colleague asked me a good question yesterday or before yesterday. Professor, if I have a product between two functions and I need to find Laplace transform of this product, can I say it is the Laplace of the first and Laplace of the second, or I can't at all, similar to the integration? Do you remember for integration, if you have a product between two functions, you can't at all integrate the first and integrate the second. And also for Laplace transform, if you have a product between two functions, it is impossible to find Laplace of the first times the Laplace of the second. So what should I do? Your colleague guessed yesterday that we need a new rule, and today we are going to study, yes, the rule in which we can find the Laplace transform of a product between specific kinds of functions. Now, Rahma or anyone, I know maybe, what do you think, Rahma? How to find this Laplace transform?
I'm not sure, but we can use the multiplication rule for integration, the UV.
Yes. So you do you mean I'm going to use the definition of Laplace transform, which is given to be integral from 0 to infinity, exponential negative st times my function. This is the definition of Laplace transform, which is e to the 3t here, my function cosine 4t dt. Now with this exponential times this exponential, I can add the powers together. So I have integral from 0 to infinity e to the, I can take t common factor. So it is negative s plus 3 times cosine 4t dt. Now, how to integrate this function, this product? How to find the integral of this product? Salma? Rahma?
Can I use the U and V?
Yes, integration by parts. You are right. Do you remember how many times do you need to use integration by parts to find the final answer of this integral?
I think 2.
Yes, we need to use integration by part twice to get the final answer. So maybe you need 8 minutes to find the final answer of this integration. I'm not sure if you want me to do this integration by parts. Actually, I'm going to find the Laplace transform of this function in 1 minute, or I can say 30 seconds. I can do that, depending on the following theorem which we are going to study. So in your exam, you can use the following theorem which we are going to study, or you can use this integral. But if you use the rule of the integration, maybe you need 8 minutes. But for using the theorem, you need only 1 minute. I'm not sure if any one of you feel it's difficult to integrate by parts. So I advise you to do the integration by parts twice here and send me your steps to check. I'm not going to do that because I need those 8 minutes to solve some problems depending on the following theorem, which I'm going to explain now. The theorem which we call it first translation theorem, or sometimes we call it first shifting theorem, and this shifting on the s-axis. Notice now, if you have a function f of t and you need to find its Laplace transform, the notation it is f capital. So if I give you f small, you will give me f capital easily. Okay, now if I need you to find Laplace transform not only for the given function here, no, I need you to multiply your function by the exponential e to the at, only t, it isn't t squared, only t. So now if you have a product between two functions, one of them is your function and the second one must be exponential at, then the answer is given to be f of s minus a. No, professor, we didn't understand this formula. What do you mean by fs minus a? I mean by fs minus a, it is the same fs which you found it here without the exponential. But after finding your answer, please shift your s into s minus the number a which you find near t here. So this is the first shifting theorem. Okay, I'm going to use it only if I have a product between two functions. One of them is the exponential. But notice, if you have the following product, where is my bin? If you have the following product, Laplace transform of t times a cosine 3t or 4t, the same. In today's lecture, I can't find this using any theorem. I can find it using the integration, yes, but you need to do the integration by parts. Maybe you need 10 minutes. In the coming lecture also, in a special case, when I have polynomial, what I mean by polynomial, t squared, t to the power 4, t to the power 7, I can find this product as one formula in 1 minute. As in today's lecture, if you have a product between the exponential and your function, so the formula of this Laplace transform is given by this. So you have Laplace transform of exponential times your function is given to be Laplace of your function without any exponential. After finding the final answer, please shift your s into s minus a. Let us apply this rule for this problem. Here, so let us find the Laplace transform of this product. I'm going to use the PowerPoint bin maybe. So I need you to find Laplace of e to the, now my function, e to the 3t cosine 4t. Yes, this is the angle here. I remember the following rule. I'm going to write the rule here down to let you understand more. The rule said Laplace transform, let me write it here, Laplace transform of e to the at times f of t, my function, is given to be Laplace of my function f of t, the same. But after finding the answer, I'm going to shift my s into s minus a. So let us apply this formula to find the answer here. So my question, where is your f in our problem? Where is the f?
Cosine 4t.
Cosine. This is my f. Where is your a? Where is your a here?
3.
3. This is my a. Focus, please. I know that most of you are good students. I believe that. But also, if you didn't study the Laplace transform this week, you can't do that in the coming one, because the lectures contain a lot of ideas, a lot of new formulas. If you didn't practice starting from today and preparing your cheat sheet, so you will find it's very difficult in the coming week, okay? Let us continue now. I'm going to apply the theorem. The theorem said you need to find Laplace of your function f, which is cosine 4t. After finding the answer, I'm going to shift my s into s minus 3, which is given to be. Now, let me ask Zaina. Zaina, do you have your cheat sheet? Or do you remember the Laplace of cosine 4t? Zaina here? Yusuf Nihrari?
Yes, doctor.
Do you remember the rule for Laplace of cosine 4t, or do you have your cheat sheet?
No, to be honest.
No. Yeah, no problem. Actually, I need to encourage each one of you to start preparing the cheat sheet. Muhammad Yasser? Thank you, Yusuf.
Doctor.
Yes, Muhammad Yasser. Do you remember the rule of Laplace cosine, or do you have your cheat sheet?
I can
check
one second.
What, Muhammad?
I will check 1 second.
Yes. You have time. Laplace of cosine.
S على S square plus K square.
You get S over S squared plus K squared. Where is the K?
4.
4 squared. And after that, because you have the exponential, you need to shift your S into S minus 3. So the answer, it will be, instead of S, I'm going to write S minus 3. Instead of each S, S minus 3 squared plus 16. This is the answer. So I can find easily, thank you, Muhammad. I can find easily the Laplace of f product between two functions, but one of them must be the exponential. Okay? Notice here. By the way, in the coming slides, we need to study. If I give you this one, so let me use this. Then just 1 minute. Give me. So in the coming slides, I'm going to give you this, and I will ask you to find your function. So Laplace inverse. So we'll go to this step, then you will go to this step, then you go here. Okay? It isn't difficult for you. Let us explain it in the coming slide how to apply the inverse Laplace transform for this formula. I have this problem now here, this one, this function, and I need you to find inverse Laplace for this function. Forget today's lecture, please, and let us go back to what we studied. I need one of you to help me how to find inverse Laplace of this function. What do you think?
We factorize the bottom.
Factorize the denominator. Great. Why do you need me to factorize the denominator? Why?
So
your
that
idea
we
is
could
right.
split it,
Why?
so that we could split it to fractions in.
What we call this technique? What do we call this technique? It's a partial fraction. Am I right?
أيوة صح.
Yeah. So now, could you please factorize the denominator? Because you suggest I need to factorize the denominator. So please try to factorize it. Or if you have your calculator, you can use it. Or anyone, please help us how to factorize this. How to factorize this? Use your calculator, please.
هيطلع يا دكتور complex number.
Yeah. So unfortunately, we can't factorize this. So if we can't factorize, do you remember what we can do if we can't factorize?
Apply theorem بقى.
Yes, I need to apply theorem. Great, Omar. You guessed that. But before applying the theorem, I need to change the form of my function.
Partial fractions.
We said we can't apply partial fraction because I can't factorize my denominator. Instead of factorizing, I think you studied something in secondary school.
Quadratic equation?
Repeat?
Quadratic equation?
Yes, what we call this technique, quadratic equation. Actually, it isn't the name. It isn't a quadratic equation, but we need the what? Do you remember the name of it?
The delta?
No. Actually, no, Abdurrahman. Look now. I'm not going to solve the denominator equals 0. No. But we need something. We call it completed square. Do you remember how to complete a quadratic expression into completed square? Do you remember how to convert it? Anyone of you? Yes?
I don't remember exactly, but I think we take the s squared plus 6s and then we add the number that can make
great.
it.
Excellent. Great. Yes. Great, Yusuf. I'm going to explain how to do that in the coming slide, but now let me give you the inverse of the shifting theorem, which we studied. Now I'm going to explain the inverse of the shifting. This is our theorem. Am I right? Laplace of a product between my function f and must, the second one to be exponential, is given by this formula. Take inverse for both sides. Take inverse for both sides. So we cancel out L with S minus 1. So we get L minus F capital. L minus F capital is given to be e to the exponential, e to the exponential. And by the way, this, it is similar to this. And also this, it is Laplace inverse of Laplace F of t, which is F capital of S. Okay? After shifting the S into S minus A is given by this. So I need this formula now. This, which is this, which is this. Now, first of all, before we start using this formula, we are going to change the form of my function to be similar to the rules. Okay? Always, I will give you a function, but this function isn't similar to the rule. You need to do something to factorize, to do completed square, I don't know, to convert the form into some rules. Let us do that together in the coming slide. So here, as Yusuf said, I need to do the completed square. I'm going to do the completed square here. Let me write here the denominator. It is s squared plus 6s plus 13. Yusuf suggests, Professor, I can or I must to complete it into square to divide this by 2. This is the idea, Yusuf. You said I need to add something and subtract something. To know that number which you need to add and subtract, do the following. Take the coefficient of s, divided it by 2 to get 3. Then squared it. If I squared this is 3, so I will get 9. So I'm going to add 9 and subtract 9. So this expression, it will be s squared plus 6s. I'm going to use another color, sorry, to write those which I'm going to add, plus 9 minus 9 plus the 13. Plus the 13. Now, first 3, those are identity. How to know this identity? Take root of the first s. Take sine of the second plus. Take root of the third 3 squared. And minus 9 plus 13, it's 4. So now my denominator is this. Let me go back here. This is the completed square rule. So my function is given to be 2s minus 2 divided by s plus 3 squared plus 4. I understand. Don't forget, Omar Salam said, Professor, I need my function to be similar to today's rule. So I need all my s to be shifted. But Professor, first of all, let us please write here the rules. So I'm going to write the rules here for those who forget the rule. 1 minute, I need the, yes, I can use the green now. So here the rule. The rule said Laplace inverse of f of s minus a. Or instead of this formula, you have Laplace inverse of f of s after shifting my s into s minus a. Or also you can say it is Laplace inverse, I'm sorry, of Laplace inverse of Laplace f of t, and I shifted my s into s minus a. All those are the same, and the answer is given to be e to the at times f of t. Professor, from where you will get this f? It is here. It is here, which is the inverse of this. Okay? Yes, we understand, Professor. From where you will get this a? It is the same. This a here, this a. Let me go back now. So for me, first of all, I need to see s minus a. To apply this rule, I need s minus a. Where is your s minus a? Where is the s minus a? Unfortunately, I see here s plus 3. So where is s minus a? It
Minus
is
3.
minus 3. So I can consider my a to be negative 3. Yes. But unfortunately, the rule said any s in your problem must be shifted. So the down you have s plus 3. So up you must have s plus 3 also to solve the problem. You can't use the rule if one of your s isn't shifted. So what should I do? What do you think? I don't need to speak. Please try to participate. Suggest any idea. What do you think? For me, look, for me, I'm going to separate my fraction into 2 fractions. to make it easier for me. So I'm going to write 2s over s plus 3, s plus 3 squared, minus 2 over, it is plus 4, I'm so sorry. Minus here, minus 2 over s plus 3 also, s plus 3 squared plus 4. I have two fractions. Yes, now focus please, and let us check if we have one of those two fractions similar to our rule. What do you think now? For me, the second one, this one, is very similar to one rule. Let me write here the rule. I know the Laplace inverse of A, or let me write k divided s squared plus k squared is given to be sine kt. Actually, this fraction is very close to this one. What is the difference between this and our fraction? What is the difference? Where?
S squared is
plus 3, S plus 3.
Plus 3. Here the problem is plus 3. And by the way, here the rule need plus or minus something. So if you have a plus or minus, so the same rule, but unfortunately you have a plus. So you will write your function and multiply it by exponential. So I'm going to write my function, which is sine of what? Sine of what?
2t.
2t.
4t يا دكتور.
4 or 2? What do you think, Omar?
لا 2 2 يا دكتور.
2. One chocolate please to Islam, Omar. So it is here, it must be e to the, also the rule said if you have shifting number you need to multiply by exponential, so it is exponential. And you told me, Professor, because it's a plus, right here, negative 3t. What about this? What about the first one? Let me use the blue to find the first one. This one. By the way, because you have shifting down, so you must do the shifting up also for the S. So what should I do? What do you think?
cosine.
It's similar to cosine, great. But here you have shifting. You can't use this rule if you have shifting in the denominator and no shifting in numerator. You need your shift to be up and down. So what I'm going to do, I'm going also to add the 3 and subtract 3. Can I do that? Because I need the shifting. So I can write now 2s plus 3 divided the same denominator, s plus 3 squared plus 4, minus 6, it will be minus 6, am I right? Or let me write minus 3, and this is the 2. Can I do that? It is 2 times 3, divided the same denominator, which is the plus, s plus 3 squared plus 4. Any question here? Any question here? Is it clear? Now please check this one. I'm sorry, by the way. Yeah, I should write here Laplace inverse. Okay, am I right here? I need to write Laplace inverse. So Laplace inverse of all of those equal also Laplace inverse here, Laplace inverse of all of those. Here we found the answer of the last one, so no need to write. Now my question about this. This one is similar to what? Let me write here the rule. I remember Laplace.
Cosine?
Yes, I remember Laplace inverse of s over s squared plus k squared is given to be cosine kt. This is the rule. So this one is very close to the rule of cosine, but I have the number shifting here. So I'm going to write the cosine of my cosine what? Cosine what?
2t.
2t يا دكتور.
2t. And you need to multiply by the exponential as we agreed, because I have shifting e to the negative 3. I understand. Did we miss something?
2 كمان.
The
2 يا
here.
دكتور.
The 2 here, yes, the 2, great. What about of this negative 3? Don't care about it. And this one it's similar to this. It is the same. So it's exponential sign. negative 3 exponential 3t sine 2t, and don't forget this one also here, negative e to the negative 3t sine 2t.
والشيفتنج ده يا دكتور دي اللي هي النيو ميثود يعني؟
A new method to find Laplace transform of a product between two functions, one of them exponential function. Okay, and I have its inverse. Its inverse is given by this formula. Okay, so you have to understand the formula, then its inverse. This is your question, Omar?
Yes, sir.
Okay, let us solve more problems, and then you will find it's simple, inshallah. Yeah, now I need to apply this theorem to solve some initial value problems. Don't forget the rule, please. And let us start solve this problem. By the way, I think you can solve this problem using annihilator technique. So solve the homogeneous associated equation by writing the auxiliaries and find the annihilator for the right-hand side, which is d squared. So it's very easy for you to solve it using the annihilator technique. In the exam, maybe I will ask you solve this problem using Laplace transform. So if you solve it using annihilator, you will take 0. Okay, and maybe I will give you, by the way, there is some problems you can't at all solve them using annihilator, and you can't at all solving them using reduction of order, neither variation of parameter. At that time, Laplace transform will easily solve them. And in the exam, you have one problem similar to those. You can't use any one of the previous techniques, and you must use the Laplace transform. Let us here solve it, but please write your names first of all. Write your names, please. Here I'm going to solve the problem. Together also, I'm going to use the yellow pen, maybe it's better. Do you prefer the yellow or white? Or no problem for you? Yeah. Do you remember the steps which I have followed to solve initial value problem using Laplace transform? Do you remember the first step? What do you think? Is to take Laplace transform for all terms in your equation. So it will be Laplace of y double prime minus 2 Laplace transform of y prime plus 5 Laplace of y equal Laplace of 1 plus Laplace of t. Now I'm going to write the rules. I remember the rule for Laplace y double prime is given to be, I forget. Can anyone help? Laplace of y double prime.
S square y
square.
capital
Y capital, great, minus
f of s times 0
times what?
y small of 0
Y small of 0, great.
minus y dash of 0.
Great, excellent. Minus 2, this 2, bracket. Laplace of y prime, I memorize this. It is s y capital minus y of 0. It's easy for me. Plus 5 of Laplace of y. What is this Laplace of y?
Y capital.
Y capital. It's y capital, great. Equal. Laplace of 1, it's very easy for me. It's 1 over s. I forget Laplace of t. Your table, please.
1 over s squared.
1 over s squared. So for those who start practicing and solve some problems of, not some, a lot of problems of Laplace transform, will find it's very easy. Especially in the exam, they will finish those problems immediately. Now let us continue. I'm going to plug in my initial conditions. So it is here s y capital, it is s squared y capital minus s y of 0, it's 0, so minus 0, minus y prime of 0, it's 4, minus 2 s y capital, minus and minus plus 2 times y of 0 is 0, plus 5 of y capital equal 1 over s plus 1 over s squared. Am I right here? I didn't do any mistake. Great. I'm going, do you remember that second step is to get y capital? So I'm going to take y capital here, y capital here, y capital here, common factor. So here my bracket, I have s squared from the first, negative 2s from the second, plus 5 and y capital. And I'm going to move number 4 here. So I have 1 over s plus 1 over s squared plus 4. Second step, do you remember second step is to eliminate the y capital. So I can write my y capital, it is, I need one to speak now. How to write my y capital? You have to divide your equation by its coefficients. So it will be 1 over the s times this bracket, which is s squared minus 2s plus 5 plus 1 over also s squared times the same bracket, which is s squared minus 2s plus 5 plus 4 over the same denominator, s squared minus 2s plus 5. Third step, if you remember, is to take inverse for all terms in your equation. So here Laplace inverse of y capital, is equal to Laplace inverse of each one of those. I'm sorry, to save my time, I'm not going to write them. I'm going to find Laplace transform of each one alone, and I will write my answer here. But small question, Laplace inverse of y capital is what? Do you remember the inverse of y capital is what? Inverse
y small t.
Y small of t is, it is my solution, which I need to find. So here, I'm going back to the new slide, and let us together find the inverse Laplace of those 3 fractions. Let me start finding the inverse Laplace of the last one. So here, let us find Laplace inverse of 4 divided s squared. I think it is minus 2s plus 5. Am I right? This is my denominator. Let me check. Yes. S squared minus 2s plus 5. Oh, how to do that? Inverse Laplace of this function. Do you have this in your table? No. If you don't have this in your table, you have to change the form. What do you think about this? What do you think about this?
It can't be factorized.
It can't?
The denominator.
Yeah, it can't. So what should we do if we can't factorize the denominator?
Complete the square.
Complete
Yeah.
square. Completed it into square. Yes. Do you remember the rule for completed square? You need, let me write the steps. I'm sorry, because I think some students need to do in front. Yes. So I'm going to divide the number here by 2, which is 1. I'm going to square it. So 1 squared, which is 1. I'm going to add it and subtract 1. So I can write my problem now. I can write my problem as the following: equal Laplace inverse of 4 divided by s squared minus 2s plus 1 minus 1 plus 5. Those 3 will be what? Do you remember? Help me,
S
please.
minus 1 squared.
Yes. 4 divided s minus 1 squared. Here plus 4. Am I right here? Let me check if I'm right or no. I will take a root of the first, a sine of the second, a root of the third, and those 2 numbers again alone. Yeah. What do you think about this fraction now? Inverse Laplace of this is similar to what? Something squared plus number. Is similar to
Sine.
Sine. You are right. It is sine, but here you have shifting, and the sine need.
E bar.
Yes. So first of all, because you have shifting, so I'm going to write e power what, David? T. 1t times sine
2t.
2t. I'm not sure if we missed something or what do you think?
P2.
So we need 2 here. Why? Because the rule of sine need up only 2. This 4 is 2 times 2. One of them for the sine, and this is the second one. we solved the first, or we found the inverse Laplace transform of the last fraction. Let me find the inverse Laplace of the first one. Maybe I'm going to find the inverse Laplace of the first one, which is, so now I need to find Laplace inverse of, I'm not sure. It is 1 over s squared minus 2s plus 5. What should we do now? What should we do? What do you think? Can anyone help?
هنقسمه 2 يا دكتور، يعني هيبقى عندنا 1 over s وعندنا 1 over s squared minus 2s plus 5.
Actually, your idea is right, but your steps is wrong. So could you please rephrase it how to do that?
يعني هتبقى 1 over s هنعملها عادي، بعدين the other one هنعملها completing the square like we did in the one before.
Look, yes, you are right. But what I can't understand how to write 1 over s alone and 1 over this fraction alone also.
Doctor, we can't.
Partial fraction يعني.
Partial fraction, you are right. So we are going to do partial fraction, and for the second fraction we have to do the complete square as we did up. You are right. So let me do that. Partial fraction, I'm going to use another color to do partial fraction. Let me use the white one. To do partial fraction, I'm going to write here, I'm sorry to write my fraction here, 1 over s squared minus 2s plus 5 equal, as you suggest, those are two fractions, a over, so it isn't 1, Abdurrahman. It isn't necessary to be 1. You have to find your a now, a over s plus, what about of the second numerator? It will be what? Here.
CS plus D.
Yes, you are right. So it is PS plus C. Because your denominator of second order, so your numerator must be of first order. How to find the constants A, B, C? Let me do or make them have the same denominator and omit the denominator. So I'm going to multiply here by s squared minus 2s plus 5. And here I'm going to multiply by s. Don't forget this s here, and this bracket here and here. So I have the following now. 1 equal a times s squared minus 2s plus 5. This is 2s, isn't it 25? Plus bs plus c, all multiplied by s. How to find your constants now? A, B, C. Suggest an idea, please.
Substitute s equals 0.
Yes, great. Substitute s equal 0, s equal 1, s equal -1. Your method. For me, I'm going to use the equating between the coefficients to find those constants. I'm free and you are free. Do what you want. As I told you in the exam, only 1 or half mark to determine the value of your constant. You can cheat from your colleague. You are free. So now I'm going to multiply the a here and multiply the s here. So I have 1 equal a s squared minus 2as plus 5a plus bs squared plus bs squared plus cs. Am I right? Now equating between the coefficients. I'm sorry, maybe I need to yes, I'm going to write here. Where should I? I can write it. I can write it. Here, first of all, I'm going to equate between the coefficients of s squared. In the left-hand side, the coefficient of s squared is 0. In the right-hand side, the coefficient of s squared, it is a and b. So a plus b. Comma. The coefficients of s, left and right. In left, I have 0. The coefficients of s. In right, the coefficient of s, it is negative 2a. C. This is C. Now I'm going to equate between the coefficients of constant. The constant now. Constant, okay? In the left-hand side, it is 1. In the right-hand side, where is the constant? It's only this. So 5a. I found easily my A to be 1/5. Great. I found that. Can anyone help to find B? Can anyone help to find B, please?
Negative 1 over
Negative
5.
1/5.
Negative 1/5. Can anyone give me the value of C? C?
2 over 5.
2 over 5.
Great. I found ABC. Now, instead of finding the inverse Laplace for this fraction, I'm going back here to use the blue color. I'm going to write here, you need to find the inverse of the following fractions. Laplace inverse. The first one, which is your A given to be 1/5 divided by S. And the second one, Laplace inverse of, where is my B? It's negative 1/5, negative 1/5 S. Where is my C is given to be 2/5, all divided by the denominator, which is S squared minus 2S plus 5. Now also I'm going to find inverse Laplace for each one of those alone. I think this one is easy. Let me write it here in details. I'm sorry to write. So the white here, the white to do the partial fraction, okay? Not for the Laplace inverse. 1/5 over S. For me, 1/5 is a constant, take it out, so I have Laplace inverse of 1/S. I remember this rule. It's very easy for me. It's T or what? Laplace inverse, it's 1. Great. So it's 1/5 times 1. Good. Now let me find the second one. I don't know if I have the space here can help or no. So Laplace inverse of, what about of this one? I don't feel comfortable to deal with this.
And separate it into 2 fractions.
Okay, so I'm going to separate it into 2 fractions. So you have negative 1/5 S divided by, and Laplace inverse of 2/5 divided by the same fraction. I'm sorry, why it is very big. Negative 2S plus 5. I don't know if yes, I have space. Great. And here you have the same denominator. Don't forget S squared minus. What do you think about the denominator? What do you think about the denominator? The denominator is very difficult to deal here. What should I do for this denominator? This denominator.
Complete square.
Yeah, it's the same. You did it up. No need to do it again. Only you can use it immediately. So it is S minus 1 all power 2 plus 4. And the same here, S minus 1 squared plus 4. In the coming slide, I'm going to find inverse Laplace of each one of those. Here, what do you think of the first one? Can I take negative 1/5 outside? So I'm going to take negative 1/5 outside. So I need to find Laplace inverse of S divided by S minus, I'm not sure it is S minus 1 squared plus 4. Am I right here? Yes, I'm right. S minus 1 squared. This is the first one. And I'm going to find the second one. Don't worry. How to find this one? Can anyone help, please? Cosine? Cosine or sine?
لا كوزين.
Cosine. But I think you have to shift your S as you did in the denominator, the same for your numerator. So I'm going here to add and subtract using the red, +1 and -1. So I can write my fraction now as the following, using the blue, negative 1/5, Laplace inverse of the first one, which is S. I think I should write -1 first. Am I right? I need S minus 1 first, divided S minus 1 squared plus 4, and negative 1/5, Laplace inverse of, it will be negative. I can't take the negative outside, so it will be plus. Or, no, I'm not sure. No, it's minus. And here you have 1/S minus 1 squared plus 4. Am I right now? What do you think? Is it clear? Let us continue.
I have a question.
Yes.
بس
Yes,
احنا from the beginning ممكن على طول اعمل الرول ان هي S over S minus 1 squared plus 4 ولا ليه لازم اعمل plus 1 and minus 1؟
I don't understand. Could you please
يعني هنا
repeat?
in the first part it's already s over s minus 1 squared plus 4 مش ممكن استخدم cosine على طول؟
No, because down you have shifting, but up no shifting. You can't use the rule of cosine immediately because you have -1 down, and you can't use the shifting rule immediately because you're shifting only down, and I need the shifting for all my s. When I see s, I need it to be shifted. This is your question?
Yes, doctor. Thank you.
Yeah, welcome. Now I have this shifting. So as Umar suggests, it is here the cosine. The cosine with the shifting. So the shifting, it is e to the, from where I will get the e,
Negative 1t.
Negative 1t. What do you think the other? Negative 1t?
لا T
T. So one chocolate, Umar, also for David. So it's t, not negative t. Am I right, Umar?
Yeah, do.
Yes, great. So Omar, maybe by the end of this semester, maybe you will, no problem. Let us continue. So cosine what? Great, Omar. Cosine what?
2 بقى 2t.
2t. Great. So one chocolate for me. Great. Continue. Minus, what about of this? It's similar to what? This one.
1 over s minus a.
But here you have squared. Which rule have s squared plus number?
اللي هي الساين بقى.
Yeah, sign. But you have shifting, so you need the exponential t. And this is the sign. Sign of what?
2t برضه.
I remember the rule of sign need here 2. Am I right? So you need to divide also 2 times 1 over 2. So here, negative 1 over 5, and here times 1 over 2. Am I right?
Yes, sir.
Yeah. Now let us go back. We didn't finish the Laplace inverse of this. So let me write it.
الشيفتنج يا دكتور بياخد يعني الاكسبوننشال بياخد باور ايه معلش؟
The rule of exponential. Do you want me to rewrite the rule of the exponential? The shifting theorem?
يعني
Yes.
الباور بيبقى ايه؟
Yes, I will write here. I will write here. The rule said Laplace transform of e to the at f of t is given to be f of s minus a. Look, if you have minus, you will write the same number. So if it is a plus here, so you will write it minus here. This is your question?
يا دكتور. Yes.
Yeah. Is it clear, Omar? Yeah. Now I'm going to find the inverse of the second fraction, this one. Take 2 over 5 outside. So you have 2 over 5. Laplace inverse of my fraction, it is 1 over, I think, 1 over, I'm sorry, s minus 1 squared plus 4. Also now it is the sign. It is the sign. Am I right? With shifting, so it is e to the t times sine 2t. I need the 2 here. So I'm going to write the 2 here and here 1. So inside, this is my problem. This is my solution. So by finding all those, collect them together. So you will add this to those here, to this one, to get your solution of the, and with this one also to get the solution of your initial value problem. Let me do also the following problem. Do we have time?
Yes, doc.
Yes. So let us do it now using also Laplace transform. Together, here the solution. It is an initial. Do you have any question before? Any question? So I can solve this one. I need to solve it using a Laplace transform. So Laplace of y w prime minus 6 Laplace of y prime plus 9 Laplace of y equal Laplace of a product between two functions t squared e to the 3t. I remember this rule. It is s squared y capital minus s y of 0 minus y prime of 0 minus 6 bracket s y capital minus y of 0. I remember this rule also, plus 9. Laplace of y small is given to be y capital equal Laplace of the separate of t squared. Can I say Laplace of the first times Laplace of the second? No, at all. So how to find the Laplace of this product? How to find the Laplace of this product?
That will be Laplace of t square. Then we replace the s with s minus 3.
Great. So Islam suggests, Professor, our method, our shifting theorem, which we studied today, if you have Laplace of your function f of t times exponential at, to find its Laplace, very easy, find Laplace of your function as usual. Simple one, and after finding the answer, shift your s into s minus a. This is the idea with which Islam suggests now. Now I'm going to apply it. But I need to know where is my f? Where is my f? Where is my f, please?
The t square.
So it's Laplace of t squared. After finding the answer, I'm going to shift my s into s minus a. Where is my a? Where is my a? Where is my a?
The 3.
Is 3. S minus 3. You are right. Let us plug in the initial conditions and find the solution. So here it is s squared y capital minus y small, y small of 0, it's 2, so 2s minus 2 times s. 2 times y prime, it is 17, and negative 6 sy capital, negative, it is 0, so it's 12 plus 12 plus 9y capital equal Laplace of t squared. I remember it is 2 divided s to the power 3. Am I right? What do you think about my memory? So after replacing s by s minus 3. Great. I didn't do any mistake here. Great. I'm going to take, don't forget the steps, I'm sorry. First step, and now take the y common factor, the y capital common factor. So here bracket s squared minus 6s plus 9 y capital. And I'm going to move all terms to the left, to the right hand side. First of all, here you have 2s, negative 17 with 12, it's negative 5. Move it here, so it will be plus 5. Don't forget here, it is t over s minus 3 to the power 3. Any question about this line? Any question about this step? Clear. Now I need to find y capital. Step 2, y capital equal 2s over s squared minus 6s plus 9 plus 5 over the same denominator, s squared minus 6s plus 9 plus 2 over s minus 3 power 3 times s squared minus 6s plus 9. Let us try to find each one alone. Okay? Which one do you want me to find first? Let me do the middle one. So I'm going to write here, that will give me third step, y small of t is given to be Laplace inverse of all those. Let me call them 1 plus 2 plus 3. Did you get the idea? This is 3, this is 2, and this is 1. I'm going to find the inverse Laplace of 2 first. Take care that this 2 in circle, but this 2 in square. So here in the coming slide, I need to find the inverse Laplace. Let me find the inverse Laplace of number 2, which is 5 divided s squared minus 6s plus 9. Who will help now? Who can help?
The denominator will be s minus 3 times
So I
s
take the
minus
5.
3 also.
You great. So the denominator, Islam said the denominator it is s minus 3 squared, not me. Who didn't understand, you can ask Islam. It's an identity. This one, it's an identity. How to find the inverse of this? Your table, please. Do you have 1 over something squared in your table? What do you think?
T.
T, great. By the way, one of the students in the previous section suggest a rule. It is modified than when we have. He said, Professor, if I need to find Laplace inverse of 1 over s to the power n plus 1, can I write 1 over factorial of n t to the power n? Yes, because our rule need here factorial n. So he divide both sides by factorial. Okay. So for me, I can see that this 2 it is my n plus 1. So here I can see, but David, here you have s minus 3, but here you have only s. How to solve this problem?
هنضرب في E باور 3.
You are
E باور
right.
3.
Here I have you are right. So here's the shifting. Let me go back to the yellow. So equal 5. The shifting e to the 3t. Okay. And this one with this square is given depending on this rule. Now my n is 1 because n plus 1 is 2. So my n is 1. So you have 1 over 1 times t. This is the t. So I think this one is very easy. Let me find the second fraction. What do we think? Let me find the second one, maybe. First one, I'm sorry. So Laplace inverse of 2s. I can take the 2 outside. No problem, 2s divided. My denominator, do you want me to? Yes, let me write in details. S squared minus 6s plus 9. Take the 2 outside and write your denominator. So 2 Laplace inverse of s divided s minus 3 all squared. Help, please. Help. How to find Laplace inverse of this function? It's divided by something. Yeah. What should I do now? You can help.
Do we need partial fractions?
Actually, if you have only one bracket in the denominator, so no need to do partial fraction. If you have only one bracket, so you no need to do partial fraction.
Can we add and subtract 3?
Great, David. I'm going to make the form of my numerator similar to the denominator. So here, using the red, maybe I'm going to use the red to write here plus 3, minus 3, plus 3. So I have now 2 fractions. So equal to Laplace inverse of the first one, which is s minus 3 divided s minus 3 squared, plus 2 times 3 Laplace inverse of 1 over s minus 2 squared, 3 squared. Any question here? I'm sorry. Here you can cancel out this with this. Am I right? So equal, let me write here, 2 Laplace inverse of 1 over s minus 3 plus 6. What about of Laplace of this one? Laplace inverse of 1 over s minus 3 squared. This one. This one. We did it here. We did it here. So it's the exponential 3t times t. So Professor, how to find Laplace inverse of this? We only need this. So 2. Your table, please.
e to the power of 3t.
E to the power 3t, great. Plus 6t e to the 3t. We finished the second fraction. I'm sorry, I need to find the third fraction here, number 3, which is 2 over this one. So you need, last one, you need to find, let me use the blue now, maybe, Laplace inverse of the numerator, it is 2 over s minus 3 squared times my denominator s squared minus 6s plus 2. I think, as Islam suggests, to write this as an identity, so I have Laplace inverse of 2 over, it's very important, this fraction, it is s minus 3 squared. Is it squared or cubed? It is to the power 3. I'm so sorry. It's power 3. Take care, please. And here s minus 3 squared. So your denominator can be written as I'm going to take 2 outside maybe. So Laplace inverse of 1 over s minus 3 to the power 5. How to do this one now? How to do this one?
The same as the above would make it e to the power of 5t.
Great. So this one, my n now, my n plus 1 is 5. So my n is 4. And for this 3, you have shifting. So the rule said, leave the 2, the shifting e to the 3t times t to the power, t to the power what here? T to the power 4. And don't forget 1 over factorial n. So 1 over factorial n 4 factorial. We found it. So we found the inverse of this, and inverse of this and this and this. I get those answers. Let me circle them in white. This one, and this one, and this one. Add them together to get your solution of the initial value problem here. Only you need to write them here. The first answer, second answer, and the third answer. What do you think? Is it difficult or easy?
Easy, inshallah.
Great, excellent. Actually, I feel most of you are good students, but you have to practice. The problem, sometimes the students feel, oh, I understand. No need to write everything by hand. Unfortunately, in the exam, if you didn't write the steps from A to Z, you can do that in the exam. You have to practice before the exam to do in the exam. Now, if I have time, I can share with you the worksheet because actually I can't join at 1 o'clock. So let me share with you the worksheet now. Give me 1 minute. New share the worksheet. This is my worksheet.
Doctor, how are the exams?
Actually, I didn't start grading. I finished the model answer, the key solution, and I will send you the solution, key solutions, and I'll try to finish them tomorrow, inshallah.
Okay, thank you.
Welcome. Now together the worksheet. Yes, I'm going to do the first one maybe quickly. Who can help to do the first one? Yeah, I have a product also now.
We can expand the sign or shine.
Sign or shine? You said sign.
What? Shine.
Shine. Do you remember the rule of shine?
E over t minus e over negative t over 2.
Yes, it is e to the what?
5t.
5t. Continue.
Minus
e to the negative
5t over 2.
Over 2, you are right. So you need to find the Laplace inverse of this product. I'm going to take the 2 outside of Laplace transform. He half, so I have. So you need to find Laplace of the first one, sine 3t times e to the 5t, am I right? Minus, here the half, and Laplace of sine 3t times e to the negative 5t. Now I have a product between 2 functions. One of them is the exponential. Don't forget, if one of them isn't exponential, so no exponential in this product, you can't use the shifting theorem. If one of them is the exponential, so let me apply the theorem of the shifting rule. So I have to find Laplace of sine 3t And after getting the answer, I'm going to shift my s into s minus what? What is your a? 5. Great. Minus. Also here, minus Laplace of my function. Where is the t here? Sine 3t. Sine 3t. And I'm going to shift s into s
plus 5.
plus 5. Great. Equal half. Laplace of sine t, I remember it is 3 over s squared plus 9. And I'm going to shift my s into s minus 5 minus half. Also, I remember the rule for sine. It is 3 over s squared plus 9. And I need to shift my s into s plus 5. Replace every s by s plus 5. You get the following. 1 over 2, 3 over s minus 5 all squared plus 9 minus half 3 over s plus 5 squared plus 9. This is the Laplace transform of this. Did you get the idea? Any question about this problem? By the way, if the students try to do it as an integration formula, infinity e to the negative st. So if he forget the rule here, e to the sine 3t, sine 5t, maybe the students need 24 hours to finish this integral. But now we did it in 2 minutes. Okay. We did similar to this, very close to this denominator, so you can do it by your own. Because I don't have time, I'm sorry. And this one also an initial value problem, similar to what we did. So please try to do them by yourself and send your solution on Blackboard. Now, do you
في
have...
الاكزام يعني لو هو السؤال زي اللي تحت ده هيقول لنا لازم يستعمل لابلاس يعني ولا احنا هنستعمل لابلاس او
Look, after 2 lectures maybe, I will solve one initial value problem which can't be solved using annihilator, can't be solved using reduction of order, can't be solved using variation of parameter. So the students will decide, now I must use Laplace transform. So Laplace transform can solve more kinds of those who can solve the chapter number 4. Okay? So no need to write use Laplace transform. The students will decide, oh yes, now reduction can't help and variation can't help and annihilator can't help, so I will use the Laplace transform. And by the way, after 2 lectures, I will tell you that here, this equation, you must solve it using Laplace transform in the exam. Clear? So any questions now? Do you have any question? So we finished the lecture today, and I hope you need to make it to understand everything and to practice. And have a nice day. Yes, Omar.
Thank you.
Welcome, Omar. Other students.
Thank you.
Welcome,
Thank
all of
you.
you. Welcome and bye bye. Goodbye, all of you.
Goodbye.
Bye bye.